Hey, so one of the questions posed to me by many developers working with me, right? So what does it take to become an architect? So this post is targeted primarily at a certain profile. That profile is essentially you're a developer, maybe like anywhere from 3 to 8 years of experience, working in either an IT services company in India or maybe a product company, been working for quite some time. So you're probably working with a suite of products. Even in IT service companies, right? You're probably associated with a project for a long time, right? You know certain applications really well. Could be a pure Java based application, for example, right? And you do a lot of enhancements and all that. So what does it take to become an architect? So when do I call myself an architect? So these are some of the questions that people ask me, and this post is specifically with that, right? So when it comes to architecture, uh, at a more formal life cycle level, right? You essentially talk of requirements. So there are requirements for which you essentially do your project, right? Now there are two kinds of requirements. One people call functional, and then you have non-functional. Functional essentially is what the kind of functionality business users expect, and non-functionals are more like constraints. For example, people might say that this is basically a low user kind of an application that I want to build. So it's going to be used by about 50 people internally, or maybe it's going to be used by 50,000 people across a broad range of channels. There will be security related needs. So anything related to performance, scalability, the total number of users, and security, and all of this essentially says you can categorize as non-functional, although the distinction is kind of blurred sometimes because security needs typically could be business requested and all that. Even from a requirements perspective, you might have among the whole, probably about 100% requirements, there might be about 10 to 15% or maybe 20% which are architecturally significant. For example, let's say the user says, some of these screens I want in my mobile devices. So that requirement essentially could be architecture significant because you need to be able to surface these kind of screens out to mobile devices, and that dictates certain additional technologies you have to use and all that, right? But then if you say that I need a customer master screen, I also need an item master screen, probably an address screen and all that. So an address, an item, all these things are not architecture significant because essentially when you design a module for UI handling and other things, everything's going to get covered. So you get the distinction, right? So you got architecture significant requirements and architecture non-significant requirements, the rest of the requirements. So maybe about uh, 15-20% max of functional requirements, which would be architecture significant, plus these non-functional requirements essentially form an input to architecture. Now, when it comes to architecture, particularly in service companies, right? One of the things I see, and if that's the only one in the architecture document, which is a real cause of concern, is the classic architecture diagram, which is that it typically goes like this. So there's one page or maybe a slide, and then you have on the top of it, you have things like the various clients. So there's a PC, there's a monitor, and then there's a mobile device, probably some other user interacting with it. Then there's a presentation layer and a business layer and a data layer, and then there's a database sitting at the bottom. And of course, you have these vertical stacks, right? Monitoring, logging, they just stack it up vertically like this. As service-oriented architecture came in, you had some additional boxes coming, which is like a services layer, and then those were also a business services layer. There's a technical services layer, all these kind of things. Now, that the question you need to ask yourself, if you are really an architect, are you a good quality architect? Is, let's say this is a diagram you have, and somebody has told you this is going to work for 50 users, uh, in a LAN environment, right? But suddenly the requirements change, so this is going to become I need this architecture to work both for these internal 50 users, plus there are also about 50,000 external users who want to access through the internet. That's one need. The second thing is this database is going to be hosted away in a separate, demilitarized zone with security and all that. There's a lot of network latency coming in. And if you're just wondering why these requirements are being given to because the diagram is not going to change, then it means you need to scale up as an architect. It's still not there. It's more a pre-sales oriented thing that you do, right? Therefore, architecture essentially is about being able to understand these requirements and form the various parts that are going to comprise your entire application, and the way they are going to interact with each other, and the various attributes going to give to each of them, right? Take some of these cases. For example, one of the things you might see is that once people say that, okay, I need these 50,000 users coming in, then once you start thinking about, hey, how do I handle this? Will my architecture handle this? For example, right now all this is going to go into the database. Now, when everything hits going to hit the database, it's going to will it scale, or will my application layer really scale? Do I need to scale it out, right? Probably deploy it in multiple boxes. But if I scale it out, how do I handle things where one request from a same user could come into different boxes? How do I handle it? Do I make a session sticky and thereby for per user always goes via a server? Is that the model I want to do, or do I want to make the whole thing stateless? And once I can be able to scale my application layer, how do I scale my database, right? So assuming using Oracle or Postgres, how do I scale this whole thing? So those are some of once you start thinking about the decision. So how do I scale my database layer? So that's another decision you might want to take. So once you start thinking on those lines, and then once you start adapting your overall visual depiction of how the application is going to be laid out, right? When it's really being developed and deployed in production, then you start really understanding architecture. So that's essentially what it is. For example, one of the things I see is that you might be a Java developer, 3-7 years, you've been working on a couple of products maybe for a long time. Just thinking purely from a Java end. That's not good when you want to design good architecture. For example, the database could become a bottleneck. For example, when you have a need where you need to process a large amount of database rows, right? Bringing them all into Java, processing them and putting them writing back to the database, that's a strict no. So you need to be able to probably assign those responsibilities into the database layer itself, so that you probably have a stored procedure that can process this. Other aspect is that distributed transactions. For example, if you're a Java guy, you can have XA, right? So you want to write to two databases, do a commit between, have a distributed two-phase commit, which is what we call it as distributed transactions, and there's an XA driver that can handle it. But then is that the good way to go? Because what we need to understand from a database perspective is that there's something called read committed, right? So when you open a transaction and you're kind of writing to it and it's going to take some time, what essentially happens is that the general model is that these transactions that you write are going to go and sit in those tables. Okay. But then when somebody else is going to read that data from the same table, they need to be able to see only the stuff that has already been committed, right? So how does the database do it? The database essentially does it by making a copy of the already committed rows into a temporary space, and then returning those rows there, while these rows which are not yet committed are kept in the table. So finally, when you commit it, that's when the whole thing process and everything becomes written into one single space, and then the next read from the table also takes into account the same thing. But then when you think about it, just think. So when you're opening a transaction, and then there are a large number of requests coming in. For 50 users, it's fine. But then when it's for 50,000 users, when so many requests come in and you're opening a transaction, you're going to take quite a few milliseconds to even to close, then that itself would be a scalable. You're going to choke the database, and that's a single point of failure, right? So those things, is something that you need to take care of. So one good way is look through some open source software. For example, if you look at some of the NoSQL databases, the way they achieve distribution and eventual consistency between them, that really gives you a good understanding and good leads on how data can be distributed in a horizontal fashion. Other thing is vertical distribution. Right? For example, let's say you have a need where you need to integrate with something, a repository like Nexus. So you need to be able to pull out all the folders and show them on the screen and other things. Hitting Nexus every time is going to be a very expensive operation. The user can't really, so you need to cache that information. Right? But then when you have caching, how do you go about this whole thing, right? Or even from a generic perspective, once you have a cache, what are the things you should do? How do we evict something from the cache? Or how do I invalidate the cache? That's something again you need to think of, because once the user is there and there's a resource that the user is going to consume, and that resource is essentially going to take a lot of time, then you need to be able to put some cache in between. But that cache also needs to have certain additional patterns. So what are the additional patterns over there? See, for example, there are two patterns, right? When you look at cache, there's something called as a write through and a write behind. When you say it's a write through, it means when you put something in the cache, then you wait for the backend resource 2 to be updated, and then you respond back to the user. Write behind essentially is about you update the cache, and then the asynchronous process goes and updates the backend resource. So there are pros and cons again between these two, correct? Because when it's a write through, it means you're going to confirm to the person or the user, or an application or some device that essentially triggered this, that everything is in proper condition, everything is consistent, the data is consistent. But then if it's asynchronous, what if the asynchronous process fails? How do you notify it back? So that's again other thing that you need to do. Now coming to transactions themselves, if it's going to take a long time, you're much better off not going for something like a distributed two-phase commit, but allowing it to write. Assuming say 99% everything is going to go through between these two databases, just go ahead and write without transactions, and then have a compensation handler. What does a compensation handler do? So if you write to this, you write to this, one of this fails, then you go and delete these two things, right? And you probably have a soft delete flag or something of that sort to be able to handle it. So that's essentially, broadly about architecture, right? At a very high level, just having this pre-sales view about drawing these layers alone, because that layers alone, the diagram itself is not going to solve anybody's problem. But then being able to understand the non-functional requirements, getting a gist of these architecture significant requirements, and being able to adapt your visual representation and the architecture, the design that you have in mind, the way all these components interact, and how these really needs to change as many of these non-functional requirements and architecture significant requirements change, essentially is what is going to lead you to become a good architect. And for that, you don't have to reinvent the wheel. Just study a lot of these open source things, right? It could be many of these NoSQL databases. It could be distributed in enterprise data fabric like Coherence, or maybe Gemstone, Gemfire, and all of this software. Just understand how they really solve this data handling issues, and across both from a horizontal and a vertical perspective. And that will give you excellent lead to be able to becoming a good architect. Hope it helped. Thanks for watching.